Hello, my name is Jonathan Harris, and I've been meaning to do this for a really long time, a couple of years actually, and I've just finally found the time to do it. Especially since my regionals is over and we're starting to look forward till GSER, we have a little bit of breathing room, and I want to start a series of educational videos that will help teams with Botball in getting more comfortable with the program in itself and just making runs that they can be confident in. And today specifically, I want to talk about something that's very important, and I wanted to get this specific video out as soon as I can so that teams have the resources that they need to work on their upcoming regionals or GSER runs. So today I'm going to be talking about specifically smart positioning and how to move around the board without messing up. So if you've been doing Botball for more than 15 minutes, you've probably seen these three lines of code right here. The motor, M sleep. This is the most basic thing that you can do to get a demo bot with just two motors driving across the board. But about 5 minutes after trying out this motor, M sleep function, you'll find that it is wildly inaccurate. And each time the robot will begin to curve in a different direction, and depending on what level of battery the robot has is going to depend on how much it curves or doesn't curve. And so, of course, the initial step and the first thing that you're really taught to do is, well, maybe if it's curving a certain direction, maybe we can reduce this value, and we can have one wheel compensate over the other, and things like that. This works to some extent, and for a lot of times this will get you to a level of accuracy that is workable as long as you have what I'm going to talk about today, which is smart positioning, knowing when to check yourself, how to check yourself, and all of the techniques that need to be used to be able to accurately position around the board. The first thing that we need to talk about is what is a square up and what is a line follow. So, because those are the two main, square ups and line follows are the two main methods that I use personally of maneuvering around the board in a more efficient way. Lots of times I use one over the other, but it totally depends on the robot and the resources that I've been given. Alright, so for the purposes of explaining what a line follow and a square up are, most of you should be familiar with a square up and a line follow, so I'm not going to go over too much detail, but I will also eventually be making videos on how to make good line follows and square ups. Code for those in the future. But right now, we're just going to talk about basically the bare minimum of what those are. Should be pretty simple. I'm sure most of you are familiar with line follows and square ups, but just for the sake of wholeness and making sure that everyone's on the same page, a line follow is just when the bot has a sensor on the front or either to one of the sides where it can bounce back and forth across a black line to be able to move across that black line without driving blindly. And then a square up would be if I had two sensors, one right here and one right here. I could have this bot drive until one of those sensors right here hits, this wheel would stop moving, and this wheel would continue to drive like this until both wheels of the robot line up on this black tape. That's a basic square up, and its purest form would be having two light sensors right here that can just read to a line as they come up to it, and you can square up on that line. But there are also sensorless square ups, which would basically be using, if instead of this was a black line, maybe we had the PVC pipe of the game board, and we were to just drive the back of our robot directly into that wall. This wheel keeps spinning, so does this wheel, and the bot just rams itself into the PVC pipe with the flat butt of the robot lining itself up against the pipe. Those are the two basic forms of a square up, is just using the black line and then maybe a piece of PVC pipe. I prefer the PVC pipe, but we'll get into that later and probably in the video when I talk about square ups. For the most part, when I think of how I am positioning my robot across the board and how I can move around as efficiently as possible, the number one thing that I am thinking about, and this is the first time I'm giving it a name, usually it's just something that I consider, but it's basically, I'm thinking about my X, my Y, and my rotation. Okay? Basically, this is a checklist that I need to be going through to know where my robot is at on the board. I think it's going to make a lot more sense when we start looking at runs that these robots. So we're going to look at these in a second. But I'm basically going to go through a checklist, and we need to keep this checklist in mind later on when we're watching runs, is the X, the Y, and the R. To know where my robot is, I need to be able to check off each of these three things. Alright, so what we're going to be looking at here is my team's run for the finals of the March 2021 online tournament. Both of these robots do a very good job of showing a good use of square ups and a good use of line follow all across this board. But I think for the purposes of this demonstration, I'm going to be focusing mainly on John Richard up here, because this bot uses line follows more than Big Bertha does over here. So let's go ahead and go through this run a little bit and see if I can point out what I'm talking about here. So let's take a look here. So we drive forward, keeping an eye on John Richard. He's going to back up. Alright, so now, alright, there you go. 2 drives in and we're already doing exactly what I talked about. We know that we need to get this bot to the most accurate position possible. So, let's think about it. Every drive and turn in between a square up or a line follow and checking your position is compound error. Alright? So let's think about compound error for a second. If you told your robot, a small little robot on the floor, with just using motor and not allowing it to touch anything, to start at a certain location, like this, drive forward 10 units, turn right 90 degrees, drive forward 10 units, turn right 90 degrees, drive forward 10, turn right 90 degrees, and get back to this location and it turns 90 degrees, after one loop of this square, you might be off 3 centimeters from your original location, and you might be off 5 degrees from where you were originally wanting to go. But what if, without checking itself and continuing to do this, we did that square 4 more times? That error is going to compound. So even though we were only off by 5 degrees on the first one, we're going to be off by 10 degrees on the next and 15 degrees on the next. And slowly that error is going to build up over time until the bot has no idea where it is inside this little square. So what we want to do, and our main goal, is to reduce the amount of drives and turns in between squaring up. You want to square up and line follow as much as physically possible. That is your number one friend. I can't stress this enough. So, what does this bot do immediately when it starts? It does 1 drive forward, 1 drive back, and a turn, and we are immediately squaring up. This is what I was talking about on the pipe square up, not the line. If you'll see here, all it does is it has the flat back of the robot, and it just drives into that pipe right there. Now, let's go back to that XYR system that I was telling you about. The X position, the Y position, and the rotation. Let's think of this Botball board as a grid. Okay? Like that. And we have and we'll call this is our X-axis, and this is our Y-axis, right? That is how we are thinking of this board, all right? So, by driving this robot into the board, we've immediately zeroed out and know what our X position is. We now know at what point this robot is on the X position of the board, all right? Now, we know that it is at this position on the board. We don't know where it is in the Y position yet. Not quite, we're about to. But we know where this robot is on that X position. But you're going to see something interesting here in a second as we continue forward with this robot. It is going to immediately, and it's hard to see in this video, but this bot is using a sensor down here on the base of it to line follow. Now we know two more things. We know our Y position because this line right here is giving us our Y position. We know that on this scale we are right here. All right, so now we know what our X position is, we know what our Y position is, and because we're using a line follow, that is automatically going to snap your rotation to be driving in the direction of this line follow. So now we have all three things: X, Y, and rotation. We know exactly where this robot is on the board. All right? So we know that that robot is not going to be off because all we have to do is worry about the bot being accurate in the distance from here to here where it's headed, because we're not going to be messing up on rotation and we're not going to be messing up on the Y because we're line following. So let's continue. This bot, you can see it correcting for its line follow right there as it drives. You can see it's that little bump right there and it's continuing to line follow. Now it's going to use that drive to pull that back and it's going to dump those into the coupler. Now, we are still line following. Right there, you can see the bot snaps to a line follow. The bot turns drastically, but then, oh, it snaps right there back to a line follow. Okay? So, then we're going to turn around. We still know where we are, right? We're going to turn around, and if you'll see, here's where line following is actually going to save us. We turn around trying to do a 180. That is not a perfect 180. We are off by a measurable amount. We need to be going like this, and we're off this much. Now that doesn't seem like a big issue at that point, but what the spot's trying to do is drive forward and move this coupler. If this is where we need to be going, and we continue that line of where the angle is going, you're drastically off in the end. So what we can do is we can reset our rotation using those line follows. So you'll see the bot immediately snaps itself using a line follow and can push directly into that coupler where it needs to be. Now, you're going to see the bot come to this position, and what it's going to do is going to immediately reset itself and find its position. So let's look. It turns, it's going to open up its claw, and it is immediately, boop, going to slam into that back wall. So let's redo our XYR, like I said earlier. So, here's your X, here's your Y. Alright? This bot has just driven into the back wall, and we know it is here. We now know its Y position. Check. Alright? Now, the bot is going to turn and slam into this wall. Boom. We now know the X position. So we know that we are in this exact spot every time, right? Because all we had to do was back up one tiny little bit here and immediately turn and find our X position. That is such a small drive and turn right there that the room for error is greatly reduced, and we do not have to worry about, and we know exactly where we are. And that's important because this precision grab this bot is going to have to do in the next second. But also, squaring up on is important to note. Squaring up physically like this on the back of a pipe inherently resets your rotation. Because it has to slam and flatten itself, you are getting the rotation. And you should be able to see it actually correct its rotation right here. Because if I think, yep, it just barely, not much, but it barely helps it rotate just a slight bit more. But now why not? It's right there where we need it to be. We're gonna go ahead and square up into that same spot again for added measure. And you'll even see that we do have some correction there from the last time. So you'll see it bumps into this corner, it drives and slams into that wall again. Now we know pretty much exactly where we are on that board because we have squared up in that corner multiple times. Now this spot will be able to grab that yellow cube, no problem. All right, now, there you go. Another square up right there on that line. We want to know where we are at all times. That is basically the second part of another double square up. We squared up here before we grabbed, and now we're squaring up here. We do that constantly. That is always and always useful and an important part of Botball, and that will help us put that yellow cube into the same exact position that we need it to be in every single time. Now we get into a little bit of a, we were very close on the line there, so that was something. So we do miss a little bit of the run there, but let's go ahead and look and see what happens here. We are going to double square up again. You'll see it happens. You'll see we back up, we grab that cube, and we immediately square up into this back line right here. There, we have our Y, right? If you're thinking of this like a grid, you have the Y. All right, so let's continue. And what do you think we're immediately going to do? We're going to turn, and we are going to slam into that wall. We now have our X and our rotation. Now we can accurately place that yellow cube into the same position every time. All right, and that's important. We need those yellow cubes to be placed the same every time because of what we have to do next for that part of the run. So you'll see it squares up multiple times there, and it's going to grab these green cubes. And just to check our position, oh, there's something important to see there. We don't know, we're kind of in dead water. If you'll see, we've done quite a few things here without squaring up. So there's our last square up. We've now turned, driven, stopped. And that's a couple diagonals and things that can get us off. So immediately what we do to get back on track is we're going to use this black line right here to line follow. Because what does that get us? Not only does it get us our rotation, it gets us our X position in this grid. All right, because we know we're on the edge of that black line. So we're going to use that line follow, and oh, look, there we square up into that back wall, helping us know what our Y position is. So now we yet again know exactly where we are on the board, and we can set those green cubes down right where they need to be. Then, just because not much accuracy is needed, we're not going to check all three, but we still square up there, we back up, and we get the 2 minecarts. So, the celebration ensues. And Alex nervously screamed. But that is a textbook run, and that is where it works perfectly. That is the XYR system to its finest. That is an excellent use case of it. Let's go ahead and look at some other runs that do or do not use this system and where maybe they could improve. I think we're also going to get one of our runs in here later because this does not work every time. I do want to say that. I am giving these methods and I am preaching these methods, but that does not mean I am perfect. I still mess up often, and sometimes runs don't work out. I still fail. That's okay. I went to a regionals, and I think we only had 2 or 3 good perfect runs. Everything else has some variance of error. But we'll talk about the variance of error and why the square ups still help with that later with a really good run by one of the Noble teams. So the videos I have today are going to be pulled from the 2019 Oklahoma Regional live stream, where basically it's a great, I mean, if you're willing to stomach it, there's about 8 hours worth of bots just running over and over again, and you can see some really fantastic designs and a lot of cool stuff going on here. But I've just pulled a couple clips from this beginning little section here that I think are going to be useful for demonstrating and looking at what I think are important to look at when looking at smartly positioning in Botball and how to be able to accurately do what you're trying to do. Alright, so first off, you're already getting off on the wrong foot here. Also, this, I will say, I don't want to just sit here and bash this team. This is a fantastic claw design. I really like it. Shifting parallelograms are always nice to see. Right here, I see a perfect use of a system where you could square up. If you'll see here, when we make this turn, it's not a perfect 90 degree. You're off just a tad. When you turn here, what we could do to make sure and check that is if you just square it up on this black line right here, there's already something that you can be doing to get yourself started off on the right foot. But we'll see how this goes. Now we drive here. Now you'll see, this is common. This happens to robots. This happens to me. This happens to a lot of people. Is when this robot drives, it starts curving pretty drastically right here until we get to that spot. Now, there you go. Another problem. He's compounding his errors. That 90 degree is off as well. And so now, instead of being perfectly lined up, right here, we are facing off to the side a little bit. Not huge at this point, but it could affect things later on. Something that we could do, and I can already see there would be a very efficient and easy way to be able to square up in this corner. What we could do is if he would just drive down and square up right here on this line, and then we make that same 90 degree turn, but then just very quickly back up into this back pipe right here, and then continue driving. Then you know where you are every single time, and you can continue confidently knowing where your robot is. So I think, oh, good, nice open claw. We have some pretty harsh curving there, and I think we get into a situation where they were trying to use either curves or gyro code, and it just did not work out for them. But let's go ahead and take a look here. After it turns, it's going to turn. We're off pretty hard there. It does look like that turn was smooth. It does look like that's gyro. Yep, that's gyro. So they open up there. They're going to curve pretty harshly. And you'll see, it looks like that's an intentional soft arc. But what happens is they've turned there, and this entire circuit here has all been without touching a square up, a line follow, or anything, and you're pretty in open water. You don't really have anything to guide you. It's basically if you told a blind person that to walk through and navigate through a room just without any senses whatsoever at their disposal, versus a blind person who is allowed to touch and hold their hand up against the wall and run their hand against the wall and walk through hallways and will know when they reach a turn, or would be able to maybe even like hold a rope in the center of the room. That's kind of the difference that we're going to see. And so it's kind of open and dead water, and you can see that we actually get a little bit of a positioning off, and that's, I think, going to cause the robots to collide. No, they get away with it. So, and you can see the team already has their square up sensors. Just right there you can see them. They have their square up sensors underneath the robot right there. So they have the capability to square up, but they are not using it to the best of their ability. Let's continue here. There we go. All right. Let's take a look at this robot. This is very interesting. Okay, so let's take a look at the other guy right here. So, oops. Ah, that's why. Let's take a look at this guy right here for a second. So, that's something that can be noted about that robot. Let's take a look at this guy for a second, all right? Let's see what he does. So he's going to, obviously, like I stated, squaring up on this black line would be very, squaring up on this black line right here would be very beneficial to him. It would help him a lot in the long run, and maybe make this drastic curve right here not affect him as much. Now, let's continue, because that seems to be off by quite a lot. Also would help if he would square up on this line right here, but it doesn't seem like he does that. Now that turns off a lot. So what you could do is you could drive up to this line and square up here. Your rotation would be the same, and you'd be good to go. Because now let's count how many, okay, yeah, so look, never once do we square up, but let's count how many turns we're off, how many turns we take before we try to do anything that doesn't work. So that's 1, and here we're gonna make 2. All right, so that wouldn't be too much of an issue, but it's the more of the degrees that it's turning. So because of how much it turns, it's going to be drastically off, because I think this claw is trying to reach this pipe over here. And what's happening is, because not only is it changing its degrees according to the board by just by just curving when it turns, you're also getting off by doing that drastic, what is that, a 270 or 360 right there? No, okay, so it's just a big 180 that was unsuccessful. But if you were to, here's the way I would fix this robot. All right, this is how I would change the path that it takes. I would have it, this distance is really far to travel without a line follow. That's something that I personally would not like to do, but my first instinct would be to come up here and line follow down this line, but his buddy's already in the way, messing with palms, and I think we actually crash on a palm there, or his run might be over. Let's see. Yeah, he's spinning in circles, but that's okay, that happens all the time. All right, what I would do, since his buddy's right here in the way, is go ahead and square up here. I don't think this is necessary yet. I don't think you need to square up on that pipe. I don't think the whole XYR system is necessary, but I would square up here definitely, and then I would continue my line, right? And then I would square up here again. That way I know exactly where I am. And then I would definitely turn right here, and then I would back up and go into this pipe just like I asked this guy to do earlier. Then this to this is a really far distance to drive, so I wouldn't do it. All right, what I would do to drive before you try to grab, what I would do is I would actually ram into this wall before grabbing the pipe. Ram into this wall before grabbing the pipe, back up a little bit, come into this wall right here, and square up. And then what you can do is you can drive, you can turn about a 45. That's getting a little cluttered here. And then once you do that, you can drive, you can turn a 45, and you can get it from this angle right here. That would help grab in that coupler much more consistently and efficiently. All right, so here's an example of a parry team that I think it's not perfect, but it uses some good elements that really help it to get some accuracy here. Because what this bot's trying to do is it's trying to collect these blue palms here and put them in this coupler over here. So for this run, I think we have some issues on this demo, so we're not going to be focusing on that. But let's look at this create over here and see how it fares. All right, so let's look. Off the grip, we have no issues there. Turning slow does increase accuracy on turns for the most part, but it looks like that's a sweep, so you don't really need much accuracy there. You're going to be fine without it. But let's see what they do here. Okay, it's been quite a while since a turn or a square up. Since a square up or anything to check your rotation. So that would make me a little nervous, but it seems to be doing fine so far. I think they're compensating with that, with the slow turns. But you do see it is getting them to them a little bit here because they're already off and do not grab that whole stack. But right here, you see something. Now that create has a bump sensor on the back, and so they drove until they hit that back wall right there, and so they immediately, if we recheck and make our grid, that's a terrible line. If we check and make our grid, and this is the Y or the X, it doesn't matter, but we now know what our Y position is, and we now have readjusted that and can accurately drive from that point. We still don't know what our X is, and we still don't know what our rotation is, but I think they cover that pretty quickly here. Yep, so here we go. They have a big metal bar on the front of their robot that they use to slam into that wall. I would suggest, if you're running a create, taking the vacuum chamber out, because that leaves a gap that is perfect for squaring up with. It makes squaring up exponentially easier. I would definitely suggest it, but if it's a weight issue or anything like that and you can't, then I guess you have to. Let's see, we turn here and we drive into this wall. So now, there you go. We get our X and we get a rotation. Textbook. All right. So Now, you'll see right there, they have, on the front of this robot, they have, I'll get a better look of it here in a second, but what they do is they actually drive until that black line. This right here is a light sensor, okay? They are driving until that light sensor connects with this black line. Not the gray line, but the black line. So you'll see right as it hits that, oh, we hit the black line. Now, that's once again, if we are looking at this like a grid, we are checking our X position. We now know exactly where we are within that space. So, that way, when we come to put this blue palm, we square up again. They're squaring up on that black, that back piece of PVC pipe. They can accurately drop that palm into that zone. Now, they still know where they are. It has not been that long since the last square up. They are going to be able to accurately get that pile. For most of these, I think if you're just turning in place, you should be fine. They're going pretty slow, so that's going to help them as well. They should get this in. It looks like they do miss a little, and I honestly think that's because they went and did multiple turns without squaring up, but that's fine. They got most of them, but I do think that is why they missed those last two palms. If I'm not mistaken, nope, they still don't here, but I think that's cool. That's really cool. You don't see that a lot. I was there. That was a fantastic run and a very ingenuitive way to get that coupler into that corner where it scores a hefty amount of points. But overall, good run from Perry team. They used square ups well, and really efficiently were able to get those palms and these cubes into the star box here. So overall, very good run, good use of square ups that can help with the efficiency a lot. Okay, so this is an important clip. I want to talk about this a lot. This is girl power. This is the Noble girls team. This is a fantastic team. They do a lot of great runs, especially in the next tournament. But I think in this tournament, actually, they won the award for the highest scoring run of the competition. It was I think 700 points, something around there. So it was a really good run. But this does bring up something interesting that I think is noteworthy beyond just the squaring up. But yet again, we're not going to be looking at this robot because this robot has issues, and I want to talk about that in a second. But right now, I want to be looking at the create. The create is what I'm interested in right now. So let's go ahead and look at what this create does, because Noble is fantastic when it comes to square ups, and sometimes they do it too much. I'm obsessive about square ups as well. They are as well. It's fantastic. Just go ahead and watch. So immediately we're turning, and they use button sensors, so there is a much softer slam into the wall. But they still, you'll see, they drive back into that wall, and you'll see it corrects the rotation. When they hit that wall, there's a slight, maybe 5-degree turn where they were already off, and it's going to correct their turn right there. So what they do is actually called line bouncing. If there is a black line here, like this, you can square up on this side, and then square up on this side, and then square back up on this side, and then square back up on this side. And that's going to basically bounce and correct your robot perfectly on that black line where you need to be. I do this as well, but I think I was talking to Jacob, who also runs a similar robot to this, and told me that they just bounce along that black line, making sure they're in their perfect position. And that is going to help them right now grab that palm stack right there. There they go. They're immediately squaring up into the back wall right here, getting their X position, and they're going to put it in that cup. Now, they're going to move that cup into the same scoring zone that Perry did, because that's a decent amount of points right there. Something to note. This is why I'm specifically showing this run. Keep an eye on this robot right here, because this is important. This is a good team, but things happen. Botball is very volatile. things go wrong for every team, and there's nothing wrong with it. All you can do is reduce the amount of risk. So I'm not actually quite sure what the catch was here or why nothing effectively clicked for this robot. I don't know where it's supposed to be at the moment. But if we continue to see, even though this robot is all up in its face, this robot is continuing to bounce along that black line and know exactly where it is. It's now going to line follow down this line. And even though this other robot gets directly in its path, it can still consistently line follow down this line. And this robot still knows exactly where it is. That should just show you the power, because I've seen this run work. What it does is it grabs 2 crates and it puts them in that drum. It's set up precisely where it needs to be. So this should show you the power of the Square Ups. Even though something catastrophic like this can happen and it can go completely cato, you're going to know where you are precisely, and you'll see that because of the Square Ups and the line follows that this robot does, she's going to move out of the way in a second, that this create can still continue its run. Now, the part of the claw broke off, so it was not able to. You'll see it turns and it can square up once again on this line, and it's already it effectively grabbed onto the position of those palms. But problem is, it lost part of its claw, so it was not able to. But it is already back to exactly where it needs to be, and it is squaring up on that line. Those have already been moved because of disruptions with this robot. But if that part of the claw had not been broken off right there, this run would be working effectively, just because that robot could continue to run in its path even with disruptions. Because and if you didn't have any square ups or line follows, and this was a regular just motor driving around the board, you would know, and most teams would know, that that would not be the case. It would get off just slightly and maybe skewed, and then the entire rest of the run is just off. So props to Girl Power. Also, just good to note, it's okay. Good teams fail too. Things happen. It's Botball. So props to Girl Power. I think both of these bots are fantastic. Awesome engineering. Some really cool stuff here. All right, here's another really good showcase of what square ups can do, or even square ups and line follows can do. So let's go ahead and take a step back from this run. Unfortunately, we did get a cut to this table, so we didn't get to see the beginning. But you can see the jostling of this robot down that line, and you know it is line following across that blue line. It line follows to there, and then immediately it's going to square up on that black line. You'll see that the transition in speed, because it slows down, it hits that line and immediately starts running and doing its tasks. And that is going to help this robot effectively get those palms into that top part. You'll see it actually squares up again. They're using a multiplied. So you'll see it squares itself up again on that black line right there. Well, you can see how off that the robot is according to the black line. Oh, that looks ugly. You can really see how drastically off that that robot is there. But you'll see as we continue, if you look, it immediately straightens itself back out, and we are lined up once again with that black tape, and that is helping that robot. Now, we are a little skewed in our X position, and I think that's why we are offset on that tower. But for the most part, it does have a curve because it knows it's going to be offset. Never mind, my fault. Good practice. They are going for 2 scoops, especially with palms. You want to grab multiple times because sometimes they miss. So going back and double dipping is heavily encouraged in Botball. There we go. Great. And now you'll see this bot does something important here. I'm probably going to have to move the camera. So let's take a look at what happens here. You'll see this is important. This robot is trying to grab this fireman right here, or this fire truck, or whatever. What it's going to do, it's going to do a soft arc here to get inside this box. It is going to use that line follow sensor on the front there to be able to line follow accurately on this line. You'll see it begin to jostle there. That is the line follow. Now, what it's going to do is it's going to use an exterior line follow sensor to know when it hits this black line. And now it can accurately get this fireman into the zone. Bada bing, bada boom. We get the points there. I think this had a start case where it had a failure in the black line, but they do have their shutdown in 119, so they are good there, nothing wrong. But good run overall. Your points here are adding up. They're gonna look great. All right, well, that's gonna be it for this episode or video, I guess. I had a lot of fun doing this. I think this is specifically going to be given to the Robotics and Botball official Discord. If you've ended up watching to the end, please DM me on Discord, give me feedback. What do I need to change that would make this clearer? What should I do? If anything to point out, is there anything you would like me to do? Also, is this something you want me to continue doing? Is this helpful at all? I'd like to hear feedback. I'd also like to be able to, not just within the confines of looking at a specific aspect of a run, I'd like to analyze runs throughout, because there's tons of videos of runs of Botball on YouTube, and I'd like to go through those and look at the things that I think are interesting that I think would really help and benefit some teams out there. Yeah, let me know. I think this could be a good resource that is going to help teams in the future. I plan on also making a couple videos documenting some building aspects that I think will be helpful and teaching teams how to build certain things, how to use certain sensors in the correct way. I definitely want to make some videos on how to line follow, like how to program a line follow, how to program a square up, and how to reduce some error in those, and even get into some more complex programming tutorials, maybe even threading or making camera code for sorting and things like that, and just making resources that teams can use in the future that are going to help them be able to elevate the level of competition at Botball as a whole. Because I would like to see every team consistently being able to do what they want to do, just to elevate the competition and make it that much more fun for everyone. So yeah, if you like this and this was helpful for you, please let me know. I'd like to hear your feedback. You can just DM me on Discord or leave a comment. That would be fantastic. Thank you. Have a great day.